Thank you very much for the introduction, and thank you very much for having me here today, for having the ability and the opportunity to talk to you and get into an exchange. I had two very wonderful presentations so far. I'm very interested in speech recognition. It's something I really would like to talk to you about it later on. So my area where I'm basically coming from is manufacturing. Yeah. So I worked a long time with the Fraunhofer Institute in Germany, and now I'm actually working very much here in Hong Kong, working with Hong Kong PC very closely together. And our history dates back 3 years by now. So the first project I was running here was 3 years ago, actually in Dongguan, with manufacturers here in Hong Kong, and helping them to do Industry 4.0, to understand Industry 4.0 and basically upgrade production. Yeah. And why is that such a topic for us, actually? So what you see here on the graphic is telling you about how many devices are connected to the internet. And when you take a look at today, 2019, it's over 35 billion devices that are connected to the internet. And the number is rising. So that means you have a whole bunch of data that are generated by decentralized sensor technology, devices, speeches, and so on. And somebody has to take those data and basically make sense out of it, make it usable, create value. So where are they coming from? What you see basically here on the top is a car. It's the Google car. So you see that they equipped a small, basically, car with a LiDAR system, which is a laser unit, basically, and helps you to get 3D images around the car, knowing the distances and being able to make decisions on autonomous driving. So they actually use sensor technology first to understand the environment and then make a decision out of it. And you see similar examples actually in wearable devices, where you equip yourself and measure yourself, understanding yourself better, knowing what's my heart rate, knowing what's my pulse, knowing how much I move, knowing how often I move. So getting those metrics about yourself. And there's actually a market for it. There are people interested in knowing status quo and moving up from status quo and improving themselves. And well, I think we've been talking about that already. Speech recognition as a possibility to get additional data about human beings and what people are actually saying. And also in manufacturing, there is the ability to gather data about machinery and being able to understand the condition of a machine. So basically knowing, is it in a good state? Is it in a bad state? Is it running well? Is it running bad? Is it producing good parts or is it producing faulty parts? So what happens right now in the manufacturing industry is basically that on a shop floor level, so where the actual production is happening, IoT, what we call IIoT, Industrial Internet of Things, are introduced into production environment. And this can be like a camera system. This can be figuring out about getting maybe like smart glasses on the worker, understanding the maintenance cycle, how you maintain your products. It's about knowing where your product is basically running through the production process. So we call this like an intelligent product. So you know where the product is, and the product tells you what processing needs to be done in order to add value. So all those devices are basically generating a whole bunch of value. And on all those data, you can actually say, they are like oil in the 70s. Yeah? They are crude data you need to use to make sense out of it, to create value, to make a business opportunity happening. So how can you actually go, specifically for the manufacturing world, how can you go from big data that are generated by all those decentralized devices in the production, in the shop floor, towards making sense out of it, to smart data? So there has been a study about that by a consultancy company that was actually interviewing top-level management people, and they were asking them, what do you do with IoT and what do you do with data analytics? Why do you need it? And top 3 answers were basically, well, first of all, I want to enable my decision-making process and make this in real time. That's what we just said before. You don't have to wait a week to actually get information what is happening on your shop floor at the moment. You can get it instantaneously. You can get it within seconds and make a decision and change basically your production cycle regarding or based on those decisions. You have the ability to reduce waste. This is something that comes actually, reducing waste is a concept coming out of Japan actually, from the lean production principles. So making things lean means reducing waste and having less waste in your production cycle. So waste is always something where you basically lose money at the end of the day. And now you can actually use IoT technology and data analytics to help you to reduce waste in your production process. And it's also the ability to predict, to predict a downtime of a machinery, for instance. So what manufacturers do nowadays, they basically run their machines, run an injection molding machine, run a CNC machine, and wait until it basically breaks down. At some point it breaks down when the tool is not working anymore, and so on. So when it breaks down, it's always downtime. Downtime is losing money. Yeah? It's basically, it's something you don't want. And nowadays you can go actually ahead and measure sensor data at your machinery and be able to see the deterioration, how it wears off, how a tool wears off. And you can make a prediction, a linear regression or a nonlinear regression into the future and say, okay, it's very likely that it's gonna break down in 2 weeks. So I have to do something before those 2 weeks basically reach, and that you can prevent those downtimes. Giving you some more examples. Who of you knows Kroger? Yeah, okay. Kroger is basically a big retail company, US-based, one of the biggest, actually. And they use data analytics nowadays. And what do? They have about 770 million consumers in their database. And they said, well, why don't we start looking at what we have on data at hand at the moment and use that to generate loyalty programs, analyze the patterns, who is buying what, how often is he buying it, why is he maybe also buying it, and have some kind of a redemption card, a card that helps you, well, when you buy like a certain amount of products, you get a recommendation, to buy other products as well, and you get redemptions. You get like 10% off, 20% off, based on your buying patterns. So what do? They actually have the ability to get their customer closer to them, because they build something like a loyalty program with them, based on data. So what does it help Kroger? Kroger helped it to actually generate some of those big revenue numbers and be a very successful company with that. Give you another example. UPS. UPS is a logistics company, right? Very well known in the US, also here, I think. Basically, they have 17 million deliveries a day. So same approach. They looked basically at their data they have at the moment. They looked at their fleets very specifically. So they have a fleet of over 100,000 vehicles. So they looked at those fleet and looked what is actually the way each vehicle goes to a customer. Basically, the way from the warehouse to directly to the customer to deliver a specific item, yeah, which has been bought off the internet. And they looked basically at the entire route of the vehicle, and by that actually on the entire route of the fleet. And they started optimizing. They started optimizing and in basically figuring out the best way to go from one customer to another by saving fuel. Yeah? So they reduced the consumption of fuel, and calculating that on 100,000 vehicles, it meant for them 50 million US for saving fuel a year for the whole fleet. Just recapping it, just looking at the data they already have, so you don't have to buy additional hardware and things, just looking at the data they have at the moment, optimizing it, and make a route planning. Give you another example. This is a picture from BMW out of Munich, actually, and they use data in their manufacturing to make predictive maintenance. So they gather at certain points in the production line, they gather information about how often is it used, what is the weight basically you have to carry, what is the force of the clamps that have to carry certain parts of the car. And they gather all those information at one central database. We call this a single source of truth, basically. It's one database that gathers all the information together, where you have enough information to make this reasoning happening. Yeah? To be able to predict in the future when we have to change a certain part or when they have to change a certain robot. So this goes all along. Data analytics and smart data goes all along with the Industry 4.0 revolution. Yeah? And when we look, as Mohammed already explained, when we look a little bit into the history, we had first starting off with the Industrial Revolution basically in England with the steam engine, yeah, the Watt engine that were actually using the force of the steam to carry force and distribute force in the production process. Then going over to mass production. So first was the ability to do something what we call division of labor. So being able to have in a production process standardized processes and then being able to do them in parallel. And later on, automation came into place, meaning PLCs, so logic, robots came into it, helping to make it a safer place, basically to not carry the heavy machinery anymore. And nowadays, it's data. It's actually the analytics of data, and which is a bit of a difference to what we heard before, to the internet industry, or where you already have a lot of data. Here, the challenge for manufacturers is actually to gather data, to make data available, to integrate the sensor technology, to have those data, to make sense out of it. When we look at data projects in the manufacturing industry, we look basically at four levels of data analytics. So we first say we want to describe something. We want to know what is happening actually at the moment. We call it descriptive analytics, being able to describe a process, to push in a transparency, to be transparent, to understand what's happening. After that, we go into diagnostics. we make a diagnosis. We know what are the upper values, what are the middle values, what is the ideal value. We can actually say this is a good process, this is a bad process. Then we are able to do something like a prediction. What I said, predictive maintenance, predictive quality control, where we say something if out of the past data we already have seen, what is the most likely scenario that's going to happen in the future and when it's going to happen. Yeah, and then react on this. Yeah. And number 4 is what we call prescriptive. This is where we go into simulation. So we have different scenarios, we can simulate different scenarios, and out of that can actually say, oh, okay, how can we react? So we can actually simulate those reactions. Does anybody know what this is? Okay, this is an injection molding machine. This is actually the PRD area and the Greater Bay Area is one of the biggest areas where they do injection molding in the world by now. So injection molding is all the plastic you have. What you are holding here is basically injection molded. Yeah? So in an injection molding machine, you have something what we call a mold. Yeah? That's basically in here. A mold is where you push in the material. Yeah? And you have something where the material comes in. So this is the plastic material comes in here and goes down, and something like a screw, basically. It's getting pushed down and getting heated up, yeah, so that the material can flow. And then it's pushed into the mold, yeah, into different molds, depends on the product. And then it cools down, and once it cools down, you take it out, and it's basically done, the process. So just looking at those machines, you have over 10 to 20 key process values. So sensor data you can look at. Yeah? So you can look at velocity of a screw, humidity, yeah? Pressure, how's the pressure behaving. You can look at the clamp forces between the molds. You can look at temperature. These are all influential variables of the process. So when, for instance, the temperature is a little bit higher, outside temperature is a little bit higher, the quality of your process is likely to decrease, for instance. So there are a lot of process variables that influence the quality of the process and how well of a product you basically churn out of the machine. And what you want to do as a manufacturer, you want to have a stable process. You don't want to have outliers. You don't want to have rework. You don't want to have faulty parts. So in order to do that, looking into data analytics, you actually have to look at 10 to 20 key process variables at the same time and be able to analyze if they are in the if they are exceeding a value, if they are in a good state or in a bad state. So you have to look at them at the same time to know the quality of your process and the quality at the end of your product, because the process influences the product quality. So what we see now in the manufacturing industry is actually they're just starting. They're not as far as the IT world, as the internet world, where data is available. Here, the first step is making them available, putting in the sensor units, getting a machine that is actually able to surveil or look at all those data, yeah, and all those values. So, as a first step, what we say to production companies is make it transparency. Be descriptive, describe your process, make it transparent, know what is happening in your production. And for that, we look at something what we call an OEE. That's an overall equipment effectiveness. It's a KPI, a classic value you basically look at in the manufacturing world coming from the lean manufacturing. And this tells you how good is my shop floor, how good is my production running at the moment. And when we look at those OEEs, we look at something like availability, how much percentage of time is actually the machine really running at the moment. Then we look at quality, so then we go back at actually all those values we just seen. We look at the quality of the product that comes out. Is it actually, do I have to do a lot of rework, or do I, how is this a lot of faulty parts, or is it really well running? And we look at the performance. How fast? Bam, 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 bam. How fast can you churn out the products? And that's describing your OEE. And the OEE is actually one of the parts very important for a manufacturer to optimize in real time, which is now possible with sensor information, instant information on your overall effectiveness, equipment effectiveness, to optimize basically based on this. To use it and to know how do I increase the quality, how do I go with availability, basically on those real-time information. This is just a rough calculation, because what happens often with manufacturers, they ask you, oh well, when we have to put all those sensor units, then I have to invest money, and when is my return on invest? Yeah. And we did a rough calculation on return on invest for OEE, for putting up those sensors, and we figured out that it's actually less than half a year that you can already get in return on what you invested in terms of sensors and in terms of hardware. So what are other parts that can be data analytics be applied? Going back to our example of injection molding, you have this different, you can basically use past data from those sensors we basically put in order to optimize the process. And so that's basically, you measure the data, you have a model behind it, you model it, and then you push back to the machine, you actuate. That's what we call a closed loop. So we sense, control, and we actuate. Something like a closed loop. And for injection molding can be, for instance, holding pressure can be optimized, the clamp forces can be optimized. There are different specific technical problems at those machinery where you can apply data analytics in. Let me give you another example in the manufacturing world. This is basically a smart box. A smart box. So classically, or normally in those boxes you have small parts like screws or like different layers, different metals. You have small parts you basically have near to your production and you have to assemble it, very much in the assembly process. So those boxes you see here, they are not just boxes, they actually have a weight sensor. So you know the weight of the material inside. So you instantly know how much of the screws are in the box. And what you do then is when you know it decreases to a certain level, a certain safety level, we call that a safety level, then you know that you have to reorder. You have to get new screws, basically, without influencing the production process. So you can automatically, the sensor unit, the weight unit can automatically basically call the supplier, and tell me, I need new screws, please deliver. And then the supplier comes to the box and refills the box. Sounds very simple, but has a high effect in the production process because it helps you to don't have any downtimes, and to actually optimize the material you have in your production to minimize that to a certain level. Because in a lean principle, you actually want to have let's say, you want to be as lean as possible, meaning you don't want to have too much material, buying too much material, because it's invest you have in your company. You don't want that normally. You only buy on demand, like when you need it, just-in-time process. Giving you another example for predictive maintenance. This is a jet engine manufacturer. So what they manufacture is basically those turbines, those big turbines you see at different airplanes. Yeah? And after some time, they basically wear off. You have to maintain them. You have to change them. You don't want to like fall down when you are flying, right? So you need to maintain them. So what the jet engine manufacturer did, he introduced sensor systems in those, basically in those propellers here. So you know how much they are used, what's the force that is applied regularly, and how long the force is applied. And by that, he's able to predict when he has to exchange the whole engine. So he's basically, he knows when to exchange the engine in the future. So he can actually offer to the plane manufacturer, he can offer a service. He can say, oh, I know when you need me, basically. And when the sensor units tell me you need to replace, you need to maintain the engine, then I'm gonna come to you and do the maintenance for you. So actually, this case is very interesting because in addition to just measuring and doing data analytics, it even opens up new business models for the companies. It opens up a new business model for the supplier of those jet engines because he can help his client much better by predicting when he has to maintain. This is another example where basically manufacturing and the digital world go together. This is also a maintenance process, but this one is basically supported by augmented reality. So you have a glass on top, and it tells you what are the steps you need to take in order to exchange a certain part. Okay, I hope I was able to give you a little bit of an example in the manufacturing and production industry, what we do with data analytics. Let me just talk a little bit shortly about the Invention Center. The Invention Center actually addresses exactly those topics, Industry 4.0. We look at both areas. We look into the production area with manufacturers, as well as we look into the early development cycles, where we help to basically develop those products. So we've been working with a lot of German companies. We're actually from Germany, so with a lot of German manufacturers together, and now had the opportunity to open up an office here in Hong Kong. We inaugurated in October, and we are basically now full in production, so to say. And we address basically Industry 4.0 topics, we address data analytics, and we look very much into product and service innovations. What you can do, for instance, what we just seen with the jet engine manufacturer, the business model, we also look very much into this direction. What different business models are actually able to you can make out of data. So thank you very much from my side.